Although there is nothing new per se tonight, you do have to mix and match several operations. And so there is a whole disciplined, logical way of approaching problems like this. I want to look at the example. Let's see, what example should I look at? Let's look at a squared to the 6th power plus negative 2a to the 4th to the 3rd power. So in this problem, we have powers and we have addition. So just like we have been doing in GREMDAS, we're going to attend to exponents first. When you look at a problem, you have to identify what is the operation, in this case it's powers, and what is the rule. And often it pays to practice with the chart next to you until you're really confident that you know the rule for each different operation. But the rule for powers is to raise the coefficient to the given power. This is a 1, so that doesn't change. 1 to the 6th is still 1. And multiply the exponents. So that gives us a to the 12th. This stylus isn't working so well. A to the 12th plus raising a negative 2 to the 3rd power, because this is powers, and we raise coefficients to the given power, it's making that negative 8, and we multiply the exponents. So that's powers. Now we're going to add. Remember, before you add anything, you have to check to see if you have like terms, and doing our very fancy little like terms test. Is everything the same? Why, yes it is. So this is negative 8. I'll put that back. So we add the coefficients, and don't forget that's a 1. Positive 1 and negative 8 is negative 7. And the variables and exponents stay the same. So you need to ask yourself, what is the operation? What are we doing with the coefficients, and what with the exponents? And as always, when you have your little exponent outside of here, that exponent is saying me first. So what if I then, instead of this being an addition problem, it was a multiplication problem? Now, I'm not going to add for my second step. I'm going to multiply. So the first step would still be to do the exponent. So these are still the monomials that we're going to be working with, but now we're going to multiply them. When I multiply coefficients, when I multiply monomials, I multiply the coefficients. 1 times negative 8 is negative 8, and I add the exponents. So that gives me 20 to the 24th. Let's take more steps involved. Let's say that I want to talk about P times negative PQ, and then that is being raised to the 4th power. And let's say I'm going to first multiply. Add it to P to the 3rd times 2PQ squared to the 2nd power. Okay, we've got our little me firsts. This is not affected, so that's going to come down. I'm going to raise my coefficient, which is negative 1. Sorry for the weird one. Negative 1 to the 4th power is positive 1. P to the, I'm going to multiply my exponents because I'm doing powers. I'm taking the raising negative 1 to the 4th power, and then I'm multiplying my coefficients. So it's P to the 4th, Q to the 4th. Now again, I'm not going to touch this because I first need to take care of my exponent. I raise 2 to the 2nd power, giving me 4, and then I multiply my exponents. P to the 2nd, Q to the 4th. Now, before I can add, I have to multiply because GREMDAS is still the order of operations. There are no grouping symbols here because there's nothing going on inside grouping symbols that we can take care of. So we've taken care of the exponent. Now we're going to do the multiplication. What's the rule? I multiply the coefficients and I add the exponents of the common bases. So I've got p to the 5th, q to the 4th. I multiply the coefficients. That gives me 1. Oops, sorry. I didn't see that 4. Let's take that over. 1 times 4 is 4. P to the 5th. And q to the, oops, I forgot the 4 over here. Q to the 4th. And I noticed that because I automatically started thinking, now it's time to add. Before I can add anything, I have to figure out if they're like terms. I take away the coefficients and look at them. Yes, they're exactly the same, meaning they are like terms. So I can combine them. 1 plus 4 is 5. And as I know from the chart, or hopefully you've begun to memorize this, when I'm adding, the variables and exponents stay the same. Because really, what this means is I've got one of this number, whatever it is. It'll change depending on what I plug in for P and Q, but no matter what, I have one of them here, and I've got 4 of them there, so now I have 5. In fact, if you chose any number for P and another number for Q and plugged it in, this expression plus this expression would equal that expression. That is what we're doing in algebra. We're learning what it would be true no matter what I plugged in. Let's see if we need to do any more. Let's just do some random. Say, I've got 2x squared plus 3x. This is sort of a trick here. Some of you may not recognize it. There's not like terms, so I can't combine. This is already simplified. Actually, those are the right word is already simplified. Okay, but if I'm asked to multiply those same numbers, I can, now I don't need like terms, so I multiply the coefficients and I add the exponents. I think that's really all we need to do now. A lot of this, it just takes practice and a lot of repetition, but if you ask yourself every time, what operation am I doing? What does that mean? The rule for the coefficients is? What is the rule for the exponents? You should be okay. If you combine that with GREMDAS, you're all set.